In this problem, we're given this function, f of x is equal to negative 13x squared minus 9x plus 5. I've graphed it out here in green. You don't have to do that, but I think what's nice about graphing it out is, one, you really understand what you're trying to find. It's not just about moving numbers around. And two, you get to check your answer to see, does this actually make sense? So we need to find f prime at 1. What does that mean? Well, f prime at 1 is, in words, the slope of the tangent line at x equals 1. So look, if you go to our graph and we go over to 1 and we go down and we see where it hits way down here, and then we draw in the tangent line as best we can. So again, I'm just eyeballing this guy in here, right about there. There it is. The slope of this line is f prime at 1. That's exactly what we're looking for. Now, you could look at this and you could say, well, I could count over and down, I can get a good approximation. We want to find it exactly. And how we find it exactly is we say that, well, to find f prime at 1, we have to take the function at 1 plus a little bit minus the function at 1 over that little bit. And importantly about this, and if you're watching this and you're criticizing it that I'm not putting the word limit out here, that's because this book hasn't gotten to that point yet. Okay, so I understand that we do need to take the limit as delta x goes to 0. So what I'm going to say here in words is that we want to let delta x become really small. Okay, that's the intuitive justification for what the limit is. We're going to push that delta x so that it's so small that it doesn't even matter anymore. And what that does is that it takes 2 points, which would have been a secant line, and pushes them towards the tangent line. So algebraically, let's go ahead and solve this. Well, we got to take 1 plus delta x and plug it into here. Now, my fear is I'm not going to be able to fit it in here, so I'm going to scroll down here. I'm going to rewrite the function, so f of x is equal to negative 13x squared minus 9x plus 5. Let me just make sure that I've written that down correctly. Okay, now we needed f at x plus a little bit, or since we're looking for it exactly at 1, we can change this x and we can put the value that it's actually supposed to be at, which is 1, because it's not arbitrary. We're trying to find an exact point right now. So that's going to be negative 13 times 1 plus delta x squared minus 9 times 1 plus delta x plus 5. So I'm just doing the math of this guy right here out right now. Okay, so negative 13 times 1 plus 2 delta x plus delta x squared minus 9 minus 9 delta x's plus 5. So that is going to give me negative 13 minus 26 delta x minus 13 delta x's squared minus 9 delta x plus 5. So what do we got here? Well, negative 13 minus 9, that's going to give me a negative 22. I don't want to mess this up just because I'm doing the math in my head. So negative 13 plus a negative 9. Yeah, negative 22 plus 5 is going to give me negative 17. So here's what I've got. I've got negative 26 delta x minus 13 delta x's squared minus 9 delta x's. So we're going to combine those. Okay, minus 17. So we're just simplifying stuff, right? So negative 26 plus a negative 9 delta x gives me negative 35 delta x's minus 13 delta x's squared minus 17. So that's going to go right here. So f prime at 1 is going to be equal to negative 35 delta x minus 13 delta x squared minus 17. That's this guy. Now we have to subtract f at 1. Well, what is f at 1? The original function, not f prime, but f at 1, is negative 13 times 1 squared minus 9 times 1 plus 5. So that's negative 13 minus 9 plus 5. That gives me negative 17, which, by the way, is the height of this point, right? This point is at 1, negative 17. Not too bad, right? Okay. So always when you're working through these, try to interpret what these numbers mean and what you're looking at over delta x. So these 17s are going to cancel, right? Because this is negative 17 and plus 17, so these guys are going to go. And I'm going to be left with negative 35 delta x minus 13 delta x squared over delta x, which is negative 35 minus 13 delta x, because I factor out a delta x. Now, the key here is to let delta x become really small, and if delta x is really small, then negative 13 times something super small, so small that you really can't even possibly imagine how small it is, that is going to be 0. So this is going to give me negative 35. Well, what is that? That is f prime at 1. That is the slope of the tangent line at 1. So apparently this guy has a slope, an m value, of negative 35. Now clearly it's negative. Okay. But that negative 35 is correct. Okay, so this guy has a very steep slope in the negative direction.